Welcome back to part 2 of our making a complete game from scratch in Phaser with TypeScript tutorial. Unfortunately, I did have to turn this into a two-parter because I did go a little long in the first part, so hopefully I'll keep the second part to under an hour. When we last left off, we had finished with our animated sprite. As you can see before you, he will load up. He has an idle animation available. See, he moves slowly, and if I press right arrow, he starts to move. Keep pressing right arrow, he moves at his full speed, and eventually he exits the scene. Next up, we're going to actually have to create the scene that he's going to walk over. Before that, I'm going to take a bit of a detour. I've got a little bit more time now. I can go into a little bit more of an explanation of how all this was actually created. That being this hero sprite sheet we're talking about. Now, I did this in a previous tutorial, so I'm not going to go into a whole lot of detail with that. You can go, there is a video, it's called something along the lines of creating a sprite sheet in under 15 minutes. I use a product called Mixamo to create a character. Then I use Mixamo animations to apply the walk scene. And then I bring them into Blender to render them. So I can quickly show you that process so you can see how you can create your own sprite sheets like what I have done here. Here are the files I've used. They're actually all included. So the blend file that I'm using right now is actually included in the GitHub and from the Gamefromscratch links. But let me just go open up the walk cycle. Here it is in Blender. Blender's a free 3D modeling software. If you haven't already checked it out, you should. Here you go. This is the Blender world. I'm in 2D view. Let me go into 3D. There you go. Here's our camera and our model in 3D. So then there you go. I framed it out so the camera is around the feet area. And all you do is you take this, you set up your camera, you set up your animations, etc. And then you come over and you just render it out to a set of animations. So in this case, they're called, let's go with walk, like so. And I'm just going to go back up and I'll click animate. So this is rendering the animation. It's going through all the frames as you can see, and it's actually rendering them out the file. And then I used the program I talked about earlier called Texture Packer. Texture Packer, there's a number of programs like this. Texture Packer is a commercial/free product, does everything we need. So just use the essential version right over here. I said for Phaser, you use the Sparlow/Starling format. All this does is determines what kind of a file is written to go with it. There's a couple other that work with Phaser, but this one works specifically. This will result in an XML file being generated as well as the ping. We've been using those all along. Those are these files over here. This walking.ping and walking.xml file. These are generated in Texture Packer. So Texture Packer, all you do is you take your frames with a consistent name. So I rendered those out to TMP. Just go ahead and grab them all, and I drop them in here. It then assembles my sheet for me. There's a couple things I want to do. First off, if you're using the free version and ping files, you have to set this down to 0 or it won't work. So ping optimization level should be set to 0. Set your dimensions however you want. You don't actually need it to be this wide. We'll go with 1024 by 2048. I want to keep it with power of 2 sizes. Which is here. That's mostly a legacy thing. It's not something that you should really be required to do anymore, but for performance reasons, power of 2 is generally a good idea. Plus, if you're going to support really old hardware, it's essential. Next thing I do is I just set this up to basic because I want it just to lay it out in a normal grid, and I don't want it to trim. So I want each grid to be the exact same size. So there you go. That's our simple sprite sheet, and now when I'm done with it, I click Publish Sprite Sheet, and it creates me these two files, which we can then include in our file. So that's the basics of how we created the sprite sheet. Now let's move on to our scene. Our scene is quite literally just an image. See? Now, this guy, a little bit of trickery went on, but basically I created this in Blender as well. Let me show you that. If you want at some point, I threw this guy together. For one, I just stole the textures off the web. I have no rights to them. They're not mine. I hope they're open source. I don't know. I didn't do enough due diligence, to be honest. But this is a very simple scene in Blender rendered out. Let me just load it up. So here you can see the textures that were used in that as well as the background. Now, what we're doing is we're creating, and we're kind of using the same texture to feed from one into the other, and the background texture is this guy. Now what I did is I cheated a little bit, and what we wanted to do is go as seamless as possible. So you notice you had this cloud here. Now if it didn't match up over here, it would look very weird. Our ground's very seamless, so if I was to put this beside and copy it and put it right here, this looks a lot like this. It's a nice seamless texture that way. Our clouds, however, do not. Well, we have a building ultimately going to be rendered here. So all I did is I went into the GIMP and I selected this section of cloud right here. And you can see basically right to there, the selection radius I picked. So I just grabbed it and then I mirrored it and pasted it over here. So this way you get a very seamless transition in the background and the clouds. And this seam you can get away with because it's actually being hidden by the building we're rendering in front. So then I load it up in Blender. And where is the file? There it is. Okay, so here it is in Blender, and there's my camera framing it out. It's a perspective camera. That's kind of a bit of a trickier one I want to get into. Let me just get over here in this 3D view. So when you're setting up your camera, if you want everything to render right, and this is something I fought with, and this is why my seam isn't quite perfect. Just go back to object mode. So when you've got your camera set up, if you know Blender at all, go over to your camera setting over here and set it to perspective. This is the angle, so it doesn't give you a 3D view. Otherwise, you're not going to get your edges out perfectly. So you can see how it's gated here. And this is set by the amount of, not focal length, it was perspective. Where'd it go? No, it was focal length, perspective. Anyways, so this is your frame out of your camera as it's set up. And then, our scene is basically a texture map box, a texture map box, a texture map road, and then another plane in the background with our sky texture. So like I said, there's the one edge of the sky. And then a little bit of cheating. I just cloned it and mirrored it like so. And then the rest is hidden. As you can see, we're only going to render part of the building. And that's how we got our scene state. And I just rendered this guy out using this camera right here. Then instead of an animation, you just render it as a single file. And kabloom. There is our background. Now, one thing you should be aware of is this file right here is actually about 6 megabytes in size. So what I did, I took it into paint.net and I turned it to an 8-bit indexed PNG, which brought it down in size massively. I also set it to 720 height. So that's my target resolution. That's why if you go back into here, you'll see that I named it scene 720p. I originally started at 1080 and it didn't give me a whole lot. So if we go back to the very, very beginning to our app, we set our internal render up as 1280 by 720. It'll run at whatever resolution we want, but internally that's what it's rendering at, and then it's scaling out from there. So I made my art aspects actually correspond with that. So now that we kind of know what we're going on with here, let's go ahead and create our scene. And scene is just another object, just like player. So I think I'm running right now. Yes, I am. So let's go over to our game objects, and we'll just do a create, add new TypeScript, and we'll call it my scene. TS. And scene again is going to be a sprite, just like we did with player. It's much simpler though, because it's not really doing a whole lot. Player has UI controls and stuff, so scene's mostly just there. Module game from scratch. So once again, we use our namespace and export class my scene. This should all be starting to look very familiar at this point. Extends phaser.sprite like so. Phaser.game, as much out of habit as anything else. Next frame is phaser.sprite. Okay, so what we're actually going to do here to make our endless walkers, we're actually using the scene, but then we're going to actually have another one loaded. So as you're walking through, it'll transition from one sprite to the next sprite. They're identical sprites, but they're side by side. So our world is going to be equal to 2 times our background sprite. And then once we get about 50% of the way through the second sprite, we'll bring you back to 50% through the first. This way you get a smooth loop forever. It's one way, a trick of doing an endless runner without having to use too much memory. You could also do this for tiles or whatever, but this is probably quite literally the easiest way to do it. So now let's come down. We'll actually create our guy. So in the constructor, first things first, let's call our parent. I'm going to call it a super, and we pass in game X, Y. Our graphic is called scene. As you can see, we loaded it here in app.ts. So let's go on back. Scene and 0th frame, like so. And then this dot next frame equals new phaser.sprite. So our sprite owns another sprite which contains the next scene, which is basically identical though. So this dot game, this dot width. All right, I'm confused for a second. Okay, yeah, so why is it 0? So we're positioning it at the far right-hand width of our current sprite. So basically in the world, we have our background, and then at the width of our background, we have another one of our background. So the y stays the same at 0. And it's also using the graphic scene, and it's also frame 0, like so. So there we created our second frame. Now this .game.add.existing, and we have to add that next frame so that it gets rendered like that. And then I got to figure out what I did wrong here. I closed my class. That'd be what? Okay. So hopefully all my underlines go away. Yeah, I need to tell it the types. Phaser.game. X is a number. Y is a number. Like that. So now it's all happy and good. So there is your scene class. Let's go on back to here. And so not only do we have the player, we now have my scene linked in. So this will bring in the JavaScript into our game world, or into our code. Now, what do I need to do? Player state. So, gameplay state, sorry. And I need to add our scene. So, let's see, I added the player up here, so now I need scene colon, oh sorry, let's call it my scene so we don't get any name collisions, my scene, and then game from scratch dot my scene. Constructor stays the same, but in our create, we now need to create a scene as well. So this dot scene. Now, there's something very important I'm doing here because it's something I'm going to do later on. The order that I add them to the world is important. I want the scene to be the first item in the world, and the order you add things to Phaser, so the order you call this dot game dot add, is the order they show up in the worlds. So in the what's the word I'm trying to, scene graph. So the scene graph's order is based off the chronological order you add them. So it's important that you add the scene first before the player, because it's something we're going to do in a little bit. So this dot my scene equals new my scene, and this dot game, and 0 and 0, like so. So my scene is going to go and create its background image, and then it's going to own another one that's going to be right beside it of identical graphics. So now we've got, let's organize this a bit. So critical. This dot game dot add dot existing. This dot my scene, like that. All right. So our scene is now added. Now we're going to do a couple of things camera-wise. First, this dot game dot world. We're going to tell the world how big it is. They're called a set bounds, and we are going to be this dot my scene dot width times 2. Right? So we have the two identical scenes side by side, so our total game world width is both those scenes. It's important so the camera knows how far it can go and when it travels, so like so. And then finally, this dot game dot camera dot follow this dot player. So now there's a default with every game in Phaser. There's a default camera made. You can add more if you wish, but you can just use the default via this dot game dot camera. And what we're doing here is telling it to follow the player sprite as it moves. All right, I think that might be enough. Inevitably, I've made a mistake somewhere. Plus, my scene is upset about something. What's my error? Semicolon, constructor, module up. Okay, class closed. There we go. All right. Now, in theory, I should be able to run this. And we're pretty much getting there with the game being a game. So there, title screen, background music plays. Click the mouse. There we go. There's our little guy, and there's our world. So now we start walking. We'll go up to full speed, and you will see he scrolls. Now, when I rendered this, I kind of did a bit of a screw-up job, and I slightly got the camera off axis, and you can see that right here. So you should probably do a little bit better of the job of your scene in the future. But as you can see, so more or less what's happening is it's following him as he goes. And the scene is like, but, we ran out of world. So we basically just did our one scene and then the next scene and then stop. So now we need to add the endless aspect. So when we get to the, I said the 3/4 mark in the second scene, we want to go back to the 1/4 mark in the first scene. Quarter being of the total size. So let's say the first one was 100 pixels and the second one was 100 pixels. After we get to the 150 total pixel marks, or halfway through 50 pixels into the second, we'd want to then go back to 50 pixels into the first, which will be an identical spot, and then we can loop forever, and we'll keep running forever. So now let's do that. In order to do that, we need to go back to our player. We're going to control it via player. It could be controlled via scene as well. It might even make more sense to be in scene, but I'm doing it in player. And now we need to implement in our update. So remember, we have this right here. This is what actually controls moving our player as time goes on. After this if, or in this if, yeah, in this if, because it's only going to happen if they're walking, we now check var stage width equals this.game.stage.getChild at. See, now I'm cheating a bit. So this is why I said it's important to add the scene as the first element of your game, because this way I can say I know that the very first entry in the game stage is going to be our scene, and this is why we did that. So what I'm saying is get the very first item on the stage, which is our background scene. Now let's get its boundaries so we know how big it is, and we want the width. Alright, so next we do a little bit of a check. If it's an if this dot x, so if our x position is greater than stage width times 0.75, so stage width is going to be the width of the entire stage, not just the graphic within. So we're going to say if we're 75% of the way through, we want to go back to 25%. So like so, and then we go this dot x equals stage width times 0.25, like so. Alright, now let's go ahead and run that. Click through our menu and hit play. And there's Bank of America. There's the Fields of Idaho. There's my bad texture scene. All right, so now we're into the second instance of the background scene. And there's Bank of America. And right now, we actually looped back to the very first one. It's behind the scenes, but our position just changed back. And there's the stream again, and so on. So now this will actually continue on forever and ever and ever and ever and ever and ever and ever. So that's our game. Isn't that really exciting? But honestly, all the skeletons there. This is how you can structure a game. This is how you can organize a game. This is animation in motion. This is responding to UI controls, playing audio. All of the guts of a game are actually here in this endless walker, except for we can't exit yet. So here, let me hit the back arrow until we stop walking, and then we're back. There's our idle animation. So now what we want to do is wire it up so that when we hit escape, it goes to our end screen. So this is going to require a couple things. First, it's going to require me to stop. So let's go back to our states. We're going to create a new state now, just for the final screen. It's almost identical to our title screen. It's just the exit screen instead. So it's a new TypeScript file. We are going to call this game over state, like so. All right, now it is. Looking familiar yet? A game from scratch. Quite obviously, you can use whatever you want as a namespace, or nothing at all if you don't have any collisions, but it is a good practice to get into. Let's export our class out from it. Class game over state, which extends phaser.state, like so. Grab a reference to the game because it's what I do. I never use it. Game over sprite is a phaser.sprite, like so. Just to be consistent, here's our empty constructor. Isn't that super? All right, so call up to the parents constructor. Now we just go ahead and implement our create. We're overriding this from the phaser.state class, and it's this dot game over sprite equals this dot add dot sprite. At the origin, it's called game over, which again, if we go back, we loaded this earlier. It's that file with that typo. All right, so where was I? Game over state. All right, and we want the 0th frame again, like so. And this dot game over sprite dot scale dot set to exact same logic as at the beginning of the title screen. This dot game dot width divided by this dot game over sprite dot width, and this dot game dot height divided by this dot game over sprite dot height, health, height, and I think that's complete. Finally, this dot input dot on down dot add. Now, instead of actually adding a method, I'm just going to do an anonymous method here, or lambda, or however you want to call it, or an arrow function, as some people refer to them in TypeScript. So that code will be called when anybody touches the screen, and simply all we want to do is this dot game dot state dot start, and we are going to flip back and clear the world because we're starting over. So there you go. So when someone touches the game over screen, it will now boot them back to the title screen. Yeah, on mobile devices, that makes a lot of sense because you exit via another means. You could exit, but in a web browser game, exit doesn't make a whole lot of sense. People just close their browser. So here instead, we're just going to loop back to the very beginning when they exit. Okay, so that's a final state. Let's go back to our index once again. We got a new class. Let's add it in like so. Go back to our app, and we have to register our final state now. So this dot game dot state dot add game over state, like so. Game from scratch dot game over state, and do not start it now, like so. All right, so we can now have a new state. When the person hits escape, we are going to go ahead and run it. The escape is controlled back in player. Let's find player. Okay, so remember we wired up escape, so that calls when they touch it. It calls the game over function. Game over function, we are just going to alter out our states. So this dot game dot state dot start. Don't forget you would normally do any cleanup you need to here. We don't really have anything to clear up. No background music playing or etc. Like so. And hopefully I didn't make a mistake, and I think we are complete. Let's run it. All right, so there's our beautiful title screen. Welcome to the game. Player presses the button. There's our game. Full speed run. We've already seen this. It loops forever. Left arrow key until nothing. And then it goes back to his idle animation like so. And then we're done with our endless running. Go ahead and press escape. And there we are at our credits. So click the credits. And I made one last error. Okay, what did I do wrong? Alright, back to that's game over state. Obviously running. I don't think that's firing. Why are you not firing? And oh, I didn't pass it context, but I don't think that should matter. We'll see. Oops. Game.state.start. My bad. Alright. It's actually there. Okay. Shouldn't have to pass the context into the input listener, but it's possible I do. I might have been having one of those thisy issues, which is always fun when working with JavaScript. So now let's go ahead and see if it was a context issue. By the way, by context, what I mean is this is a mutable value in JavaScript. It's horribly implemented. So if you're from a Java or C++ background, you're used to this basically being whatever object you're currently in. The brilliance of JavaScript, they decided that this is going to be contextual. So if you're in a class that has an onClick event listener, this is actually the event that passed in the click, as opposed to, it's a very illogical system, but most people got around it by more or less allowing you to pass this as a parameter, which is what I've just done. So let's see if that's what it was. We'll press escape. That wasn't what it did. Oh, is that actually even the state? I'm an idiot. All right, I just typoed. Game over is state, not start. Oops. It helps to actually call the state. Now, this is one of those things that's actually kind of annoying at times with Phaser. Stop the music. It will actually allow you to run bad code, like I just did there. I just passed it and it didn't throw any errors at me or anything. It's one of those things you're going to be scratching your head a little bit. Learn to love your debugger. Walk through your code. You'll find these errors almost instantly. They'll become sort of second nature to you eventually. But now if I hit escape and I press the button, we loop back to the beginning. So title screen switches state out to the gameplay state. You play your game, as amazingly fun as it is. And then when you're done, you hit escape. It loads to the credits screen or the final screen. And then when you're done, it loops back to the first state. So as you can see, shut that down so I don't have my music. Game is controlled. You break your game up into separate states. States can be, if you had different game modes, it would make sense to switch between them. But in this case, a lot of times, and most games will actually have it as the game itself is a state, and then the settings and exit or title are separate states. But the majority of your logic will be in one particular state. And as you saw, I split things out into game objects, which were inherited sprites. The game lifestyle works so you implement update, calls each frame, and you can update your logic there accordingly. Input can be handled at whatever level you want. We could have handled input at the top level. We could have pulled it. We did all event driven in this particular example, but so a quick walkthrough of exactly, now that we're finished here, that is the complete code. Once again, it's available on Gamefromscratch, and I'm going to make a GitHub link available as well. And in that, there will be a folder called Assets, which will have all the blend files, textures, and everything used to make this, if you want to tweak and play around with it yourself. But let's go back to the very beginning. So it all starts, the index file is loaded. The index file then goes and loads all of these different JavaScript files. Keep in mind, these JavaScript files are being created by TypeScript, by the TypeScript transpiler. So JavaScript is turned, a TS file is turned into a JS file. If I actually go behind the scenes here to the project we're working on here, you'll actually see, so in game objects, there's actually a JS file being generated and a player file being generated. So I'll show you. Here's scene. Here's the code that's being generated. It's actually quite clean, quite easily read. And that's what's happening behind the scenes. TypeScript compiles down to JavaScript that looks like this. So here's your namescape, your namespace. And so instead of typing this, you just do that module at the top, and it turns into disclosure, etc. So back to the beginning. All of the generated JS files, including, most importantly, in order, bring in the Phaser one first, and then your starting game application, but then all of the other things that are part of your project. And then with the JS, the app.js file is called, which is sort of your program's main. And then it brings you into this familiar guy. Here we created our game in the constructor using that default resolution. And then in preload, we load all of the assets we're going to use for the entire game. And we create our various game states, which are objects inherited from phaser.state, including the title screen state, which we pass the value of true, basically saying, yes, true. Go ahead and run this as you're creating it. This then leads to that code executing next. This entire code is itself fired off by the window on load event, which causes it to be one of these objects to be created in the first place. So then obviously then the constructor gets called, and then all these different methods get called by the phaser engine at this point. So once you're past your constructor, phaser is now running your event loop for the most part, and then calling your update and render and draw methods, etc. So at this point, our program execution kicks over to our title screen state. Our title screen then loads up, and its create, all it does is add the sprite, plays the background music, and then puts a tap handler waiting for the person to tap the screen. When the person does tap the screen, we stop playing our music, and then we kick over to our gameplay state. Our gameplay state is where the majority of our game takes place, but it itself is quite simple. It creates the player and the scene. The scene being first, because we're going to access it by index later on. You could have done it by name or tag or whatever, but index worked easily enough for this example. So it creates the scene and the player, adds them in, and then it sets the world's dimensions up and a camera set to follow it. Finally, that then kicks into our scene itself. Doesn't really do much. All it does is creates a twin of itself. So we have two identical images back to back, and they're constantly going to be drawn from one to the next. And then the majority of the magic happens in the player. The player comes in and mostly just registers a bunch of input handlers. So you can hear the left arrow, the right arrow, and the escape key. Next up, it creates a graphic of itself, and it starts off being idle. The idle animation is all controlled by this player state enum that we created earlier, but you load in the idle texture. So when you're switching between animations, you do so by using a load texture call. Now it adds an animation called idle that uses all of the frames in that texture. So again, if you had multiple animations, multiple different animations in the same frame, you could instead have passed, so let me here just show you. You can pass in the frames, the rate of frames, etc. So you can control exactly how it's controlled, but since I want to use all of them, I just go ahead and set it this way. And then finally, I start the animation playing. In this case, I say play it at 15 frames per second and loop it forever. So now the player basically is just sitting there twiddling their thumbs, quite literally, until the player hits a button. So if you hit the right arrow key, then we kick into the move right. Move right comes in here and it toggles out the status. So now we want to go into start walking. Start walking changes from the idle state to the walking state. It updates the texture, creates an animation called walk using all of the frames in that texture, and then starts it. The speed is relative to however many times the key is pressed. By pressing the right arrow changes the walking speed, which in turn changes the animation. Remember though, you have to update the current animations.speed value as you're changing that value. There's no direct link otherwise. But this is what causes the animation speeds to increase and decrease, is this call right here. So finally, the user potentially presses the escape key. The escape key will cause the game over call to be called, and this clicks off the game over state. Game over state, once again, is almost exactly the same as the title screen, except for no sound effects playing. So it basically just draws a sprite, registers a non-click handler. When the person touches a key, it then flips them back to the original, and we begin it all over again. So there you go. That is a very simple game, completely from scratch, using phaser and TypeScript. Obviously, there's a whole lot of things we didn't cover. We didn't cover physics. We didn't cover bounds checking, tile maps, all kinds of things are available in there, but it does get you the basics. And if you're interested in more, once again, I've done a complete tutorial series that covers everything we just did in depth, text only, on Gamefromscratch.com. You should go check that out. If TypeScript isn't your thing, you can also look at the generated JavaScript. This whole thing should probably still help you, even if you're working in JavaScript. In the GitHub repository, all the .js files will be committed as well. Once again, you can go to Game From Scratch. There will be a link in the bottom to the actual supporting documents that go with this, as well as to the GitHub page. I hope you enjoyed that. I hope you enjoyed Phaser. It's very, very cool web technology. You can do a lot in very little time. So I hope that was informative. See you next time. Cheers. Bye.